Welcome to Maths Prowess. Here we have an Olympiad question before us. X to the power of 2 minus y equal to 31. Y to the power of 2 minus x equal to 31. So what are the pairs of x and y that will satisfy this expression here? Okay, so from here, let's take cancellation. Now, looking at the two equations, you discover that on the right-hand side, we have 31, we have 31. So it tells me that equation 1 is equal to equation 2. So if we are to equate equation 1 to equation 2, so this will give us x to the power of 2 minus y equal to y to the power of 2 minus x. So if we bring all the terms on the right-hand side to the left-hand side, then we'll have here x to the power of 2, then bring this to this side will give us minus your y. So let's take this first. So we have here plus your x, then minus y, bring this minus y to the power of 2, everything equal to 0. If you take a look at this, there's no way we can factor this and factorize this to give us something reasonable. So let's bring this that is carrying a square and this together. So we have here x to the power of 2, then minus y to the power of 2, then this and this together, we have here plus your x minus y equal to 2. Okay, now if you see these two here now, what comes to mind is difference of 2 square. Okay, so if we have difference of 2 square, our difference of 2 square says that if you have a to the power of 2 minus b to the power of 2, this is a minus b bracket, your a plus b. Okay, so this is what the difference of 2 square says. So if we apply this, then we can bring out something of such here. So we're going to have here to be x minus y close bracket, x plus y close bracket. Then we have our term here plus our x minus y equal to 0. You discover we're having x minus y. So let's factor x minus y out. So we have here x minus y close bracket. If we use this to divide this, we're left here with x plus y. So we have here x plus y. If we use this to divide this term, we're left with plus 1 is equal to 0. So what we do next here? From here, we apply the zero product rule. What does the zero product rule say? It says that if you have your a times b, this is equal to 0. So it also means that your a is equal to 0 or b is equal to 0. So this is another rule again we're going to apply. What happens here, then we can equate this to 0, So we now have this to be your x minus y equal to 0 or your x plus y plus 1 equal to 0. So this side, let's handle this. This terms means, okay, let's separate this out here. So this terms means that our x is equal to our y. But then what will be the numerical value of our x that will be equal to our y that we will put it into the original equation? There we have something to give us 31. So from here, we go to our equation 1. From our equation 1, look at our equation 1, which is x to the power of 2 minus y equals to 31. So we now say from equation 1, which is x to the power of 2 minus y is equal to 31. So we make y the subject of the formula. If we make y the subject of the formula, this will give us x to the power of 2 minus 31 is equal to y. So we can put our y in place of this. So if we do that, this will now give us here. This now implies that our x is equal to x to the power of 2 minus 31. When we rearrange this, this will automatically give us x to the power of 2, then minus your x, then minus 31 equal to 0. This is a quadratic equation, of course. The only way out is to use the quadratic formula. So using the quadratic formula, we have our x is equal to your minus b plus minus the square root of b squared minus 4ac all over 2a. What is our a, b, and c? Our a from here is equal to 1. the B is equal to minus 1, and C is equal to minus 31. So if we substitute, we're going to have our X is equal to minus bracket minus 1 close bracket plus minus the square root of minus 1 squared and minus 4 times 1 times minus 31. Okay, so everything here all over your 2 times 1. So if we simplify down, we have this to be 1 plus minus the square root of 1. Here we have minus times minus will give us plus. Then 4 times 1 will give us 4. Then 4 times 3 will give us 12. So 124 all over 2. So this is equal to, we have 1 plus minus the square root of 124, 5 rather. So 125 all over 2. So 125 can be split into 2, which is your 25 times 5. And the square root of 25 is 5. So we thus have this to be 1 plus minus 5 to the square root of 5 all over 2. So mind you, we're having our x down here, so we have our x here. So automatically, we are having our x1, which is equivalent to our y1 is equals to, because from here we said x is equals to y. So therefore our x1, which is equals to our y1, is equal to, we have two solutions from here, that of the plus and that of the minus. So we have here your 1 plus minus 5 into the square root of 5 all over 2. Okay, so if we are to split this again, so let's cancel the out, and we take our s2 from here. We have our x2 is equals to y2, which is equals to 1 minus 5 into the square root of 5 all over 2. So this is our x1 and x2. Okay, so since we've gotten our x1 and s2 from the first expression here, so let's look at the second side of the equation, which is this. So how do we solve this? Here we have two unknown. We cannot solve for these two unknown. So again, we go to our equation 1. From our equation 1, if you recall, we made y the subject of the formula here. So let's go ahead and put this expression in place of y. So when I have this to be your x plus your x to the power of 2 minus 31, then plus the x1 here, then equal to 0. Then we can add this and this together to give us x plus x squared minus, here will give us 30 equal to 0. So if we rearrange, we have our x squared plus 1 minus 30, or plus x rather, then minus 30 is equal to 0. Now this is a quadratic equation. Now from this quadratic equation, we can use the factorization method. So we think of two numbers that we will add together, we give us plus 1, then multiply together to give us minus 30. So the two numbers will definitely give us 6 and 5. And the signs will be plus 6 minus 5. So we can rewrite this expression here as your x to the power of 2 plus 6x minus 5x minus 30 equal to 0. So we put this and this in bracket this. So let's factor out x from here. We factor out x, here we're left with x plus 6 close bracket. Then we factor out 5 here because 5 is common. So we have here 5 will be left out. We use 5 to divide this. Mind you, minus times minus will give us plus sign here. So 5 into 30 will give us 6. Everything equal to 0. Now, if you look carefully, you discover that what we have here and what we have here are the same. So we take the one inside the bracket and we take one outside there, which is x and minus 5 close bracket, everything equal to 0. Again, remember the zero product rule, which we'll look at the other time, which is this. So if we apply this zero product rule again, so we're going to have this to be x plus 6 equal to 0, or x minus 5 equal to 0. So we have our x is equal to minus 6, or x is equal to positive 5. From here, we look for the value that will correspond to our x. This is our x3, this is our x4. So look for the value of y3 and y4 that will correspond to this from this equation here. Okay, so for us to look for y, if we make y the subject of the formula here, we're going to have our y is equal to our minus x minus 1. So all we need to do is to put this value for y4 into this. So we now have here y3 is equal to minus bracket minus 6, but that's what we have here. Okay, then minus 1 here. So everything, this will give us 6, then minus 1, which is equals to 5. So our y3 is 5. Our x3 is 6, and our x4 is 5. So we do same for y4. y4 will give us minus, we have 5 here, so minus 5, then minus 1, which is equals to minus 6. So our y4 is minus 6. So in all, we can bring out all the pairs of x and y that will satisfy this expression or this system of equation. So therefore, we cannot say here that our x, comma y, the first one we solve for x, this equal to, you have your 1. Okay, so we have 1 plus 5 root 5 all over 2, comma, your 1 plus 5 root 5 all over 2, close bracket, comma. Then the second one, which is our x2, we have our 1 minus 5 root 5 all over 2, comma, 1 minus 5 root 5 all over 2. Okay, so we have this, and the next one, which is our x3, y3, we have bracket minus 6, comma, the positive 5. And the last one, which is x4, y4, we have bracket 5, comma, minus 6. All right, so I've gone ahead to put all these values into the expression we have here, and they all satisfy the equation. Okay, if you put each of these pairs here into the original equation here, then you discover that they will all satisfy this system of equation. This is all I have for you for today. Bye. But if you've not subscribed to my channel, subscribe to my channel, because we roll out good mathematical Olympiad all the time. Bye for now.